Hi. Uh, there is this kind of news like everywhere now in Finland about this kind of storm which is coming. Huominen Vienon voimakkaan. Huominen Vienon myrsky on vuoden aikaan nähden erittäin voimakas. Voi aiheuttaa kovempaa tuhoa kuin talvella vastaavien tuulilukemien myräkkä. It means that this Vieno storm is really strong for the time of the year we're living in. It probably destroys more stuff than the same kind of wind in winter, of course, because there's no leaves on the trees. And I was reading that and I found one interesting. And here I talk about 20 meters per second wind, and they are really baffled. There could be like rain, 30 millimeters, which isn't that much after all. So the funny thing is that one. Näin myöhään kevästä tällainen myrsky ei ole kuitenkaan kovin yleinen. This means it's a little bit oddly written that it basically means that late after spring, this kind of storm is not common. And first I thought that's really funnily said. That late after spring, this kind of storm isn't really common. But I will show you something. This one. Yeah, I had to search it first, I know. But anyway, it's a bit hard to see the axis of Earth. It's a little bit tilted. It's roughly said like that. So, this kind of storm after spring is not very common. The spring equinox, which was at the 20th, so we are going towards the 20th here. I think this is what he meant with the spring, because the angle of the sun is different in winter than it is in summer. This is why we have like the equator thing, equinoxes, when we go to the other side. This is the thing what he meant, I guess. So I had to check about the equinox day that I wouldn't talk any funny stuff. So this was that about this storm. And I live about the 63.5 degree north. We are here at Null School. This is our globe. What we are watching is the wind. And we are at the highest you can go. SFC means surface. So we are at the highest. And I want to show you something. First of all, this line here, let's go closer. This white line here is the equator. Okay? This stream should be here at the equator. But obviously it isn't. I guess you can agree with that. So, if we go further on, let's go to the South Pole and check out if there's any wind. There is. 271 kilometers per hour. $275. Okay. That's the South Pole. I hope that you notice that those are spinning in that direction, those are spinning in this direction. And that's a good thing. So, what do you expect from the North Pole? This relates really strongly to this storm which is coming this night. It started already to wind. Like it's windy all day already. So, North Pole, that's the South Pole. More than 270 kilometers per hour winds on a big area. Really big area. Let's go to the North Pole. Notice something? 30 kilometers. 68. Well, here it's red. Yeah. 29. 40. 29. On the South Pole we had 270 and more. Did you notice the other thing which is interesting, at least, so to say? This is going that direction. And this is going that direction too. This goes that direction. This goes in that direction. Which is a good thing. This doesn't look good. Healthy. They should go in that direction too. At least some once said about that. It's really important for whatever things in nature, or like that's one principle in nature, how to say, obeys. It's equilibrium. So, this doesn't look something in equilibrium. There are many odd things here, for me at least. They look strange. We have this region which goes, does it go around the globe? Yeah, it goes. I don't know what's going on here. That's a really strange place. Because as far as I know, the South American magnetic anomaly is on that side. But I'm not sure about that. It could be also on that side. We could check this one out. But anyway, that's a little bit odd, isn't it? This doesn't look like it should at all. Let's hop over to another funny thing I noticed. Yeah, it's back. Finally. Magnetosphere model. As it's called by name, it's a model. It doesn't represent like reality in the way reality is. So, let's just play it. There's something going on. If you go to this really start, everything's okay. There's nothing going on too much. And then after a while it starts and it's somehow flickering, like really flickering. Somewhere here it's the first initial hit of something. You see on the top side how this line is bending. And as we go on, it takes these really strange shapes. There's like this kind of many hits, hit after hit after hit. And after a while, if you take a close look at this area, or maybe a bigger, this area, there is this thing coming. I say this thing coming from the back to the front. It looks like that because that's a sphere cut in half, so you can't really tell if it's coming towards you or is it going away from you. Do you understand what I mean? So it somehow appears that it goes to the wrong direction. Could be an optical illusion, I don't know. You see? It goes forward. Like those two. Like, it looks like a crab. What a scissor, or how they are called. Anyway, that's an interesting spot to watch. Keep your eyes on that. Well, let's stop here. It seems that there would be this kind of opening. And here, there's something going on too. So, there's obviously this kind of opening. Obviously, there's something connected to here, to here. I don't know what this means. Induction energy gets pumped into Earth's electric circuit. Probably. I don't know. And the other thing is, like as I showed you before, there was almost no wind on the northern hemisphere, northern pole. But in this model we have this red area, which is quite persistent in place over the northern part of Earth. So like if solar wind is coming here, like from this, like the pressure is coming from there, you can't really expect that this red stuff is exactly over here because it gets pushed back by the pressure. Question is, why isn't here anything red too? You know, it should be in equilibrium, because basically there should be a straight line and that's the sun. It's not that the sun would be down here or up there. This should be straight. There's much more going on the northern hemisphere than on the southern hemisphere. Even though that our opening is on a way on the southern part, because that's the equator. And this line looks also really interesting. There's something going on. Because it's kind of in the middle, in between that and that. And also that it's in the middle of those two things. I don't know if this means anything. And if you watch it now at this back area, there's stuff going on, and we have still red here on the northern hemisphere. Oh, so that's really interesting. This. Somehow it emerges and then it goes down here. There's actually a second one. This one. Right after the first one. That's the first one. This. Let's call it plume. Of whatever it's made of. I have no idea. First one. Second one. It rises up. There's one. This one. And in the next frame, it goes kind of like that. That's the first one. Next one goes from this to that. Some kind of discharge event. I have no idea. But we have those two. And then we have this plume, and there's one going there. And then we have here, basically not that much going on, but here we have something going on, and also here, which is quite close to the surface of Earth. Yeah, that's Earth. Not this one. Anyway. And remember, I still talk about the storm in Finland today. Compare this to the southern hemisphere as we go on. And I just noticed that we are almost the whole time connected on the back side of Earth towards the equator. Yeah, this is what I noticed earlier. Watch that region here. How does it behave? Somehow it looks like something would dissipate, or how to put it, torn away. Now let's start here. It gets a bit red, and then it elongates, and then it elongates more, and then it gets cut off. This cuts it off. After that, it's gone. And the second one follows. Which is actually quite big. Equilibrium. North and South Pole. On the southern side we have this one, bow shock red. On the northern side, here, there's nothing going on, but instead we have this thing here. And we have a storm which shouldn't be in summertime, because those kind of storms, they usually appear in wintertime when we are on the other side. Like as I described before, if that's the sun, we are like this. And depends if you're in the southern or northern hemisphere, but anyway, if that's a straighter line, please. Yes, if this would be a straight line. For some people, it's summer and winter. Winter. So when you cross that, that's the equinox. I don't know how to write it. Equinox. Probably. I don't know. Doesn't matter. You get it. So, equilibrium here. I don't see any equilibrium here. Sorry for that. There's no equilibrium here in that. Is there anything else open? Yeah, check it out. The squiddy. They put new colors in it. Really nice. Thanks for that. Amazing. What a development. IMF lines flying around just from the southern side. Yeah, north and south. And one other thing is probably worth noticing. I don't know if there's anything to that. It's not straight, it should be like that. For whatever reason. Is it because our plane in which we circle the sun goes up and down? Does it go that much up and down? I don't think. Yeah, some release in our tail. There was something interesting earlier, I noticed. Yeah, again, giant magnetic bubbles rebound ions from the atmosphere. Yeah, I don't know. There was nothing here, I guess. Or I forgot it. Yeah, the storm. And after that, it's gonna be really hot here. I bet it won't last too long. And after there's like, now it's a storm. After that, it gets really hot. And after that, probably some thunderstorms, I guess. Because, you know, it's just how it goes. And the interesting thing is, even though that I said probably that there will be no summer here in Finland, now it gets really hot. But I don't know, it doesn't seem really that the weather is doing stuff as it is supposed to do. This is 2 days old, and that's the original. You can see like these clouds, they are really high up in the air, and those aren't. These are basically the ones on the right are usual clouds, and the ones in the middle of the picture, they are really high above. This is a little bit an enhanced version of the same picture, because I really wanted to show you that those riplets are everywhere. You probably can't see it in the first picture. And those little clouds were more high up in the atmosphere. That's the sunrise. And it's really hard to somehow show you what like these. I bet these are noctilucent clouds, because they are really high up. They usually don't appear on any satellite images or whatever. They are really high up. They don't move quickly. They transform, they change their shapes, but they don't move, basically. They are quite much stationary. And the thing is, like, here's a picture you can probably see. For example, these clouds and these clouds. And these and these. They are normal clouds. But this one and this one, and also the small one here, and those, I say they are NLCs. If you compare this one and this one, this one is dark and that's really white. And that's the original picture. I didn't do anything. And there would be more here in the proximity of the sun. Here is actually this one. But there would be also here. And there should be somewhere a picture of those. Here you can like really well see the color difference between those. They are really shiny. Those aren't. And I say these and these are probably at the same height. This is a little video clip. As you can see in those pictures, probably you noticed those darker clouds, they move. And those others higher up, they don't move that much at all. Yeah, this picture. Funny. And these kind of things, they aren't long in the sky. A blink of an eye and they're gone. I noticed this one here. That's a funny one.